This video discusses programming for RiskOptimizer. Although RiskOptimizer is now totally integrated into at-risk, it has its own object model and XDK. Whereas at-risk's objects generally start with risk, as in risk simulation, risk graph, and so on, RiskOptimizer's objects generally start with opt, OPT. Nevertheless, the XDK for RiskOptimizer is quite easy to learn and use. It does exactly what you would expect it to do. It allows you to define the goal to optimize, specify the adjustable cells and their solving methods, specify the constraints, if any, and run the optimization with specified stopping conditions. This video will briefly explain the process. Then you can examine the RiskOptimizer XDK example files for more details. The file shown here, RiskOptimizer XDK Object Model Diagrams, plays the same role for RiskOptimizer's XDK as the similar Object Model Diagrams file does for the at-risk XDK, so I will use it to discuss the possibilities. Here is the RiskOptimizer object model. As the explanation at the top indicates, you should set a reference to RiskXLA as you do for at-risk automation. After all, RiskOptimizer is part of at-risk. But you should also set a reference to the RiskOptimizer Excel Developer Kit. Of course, you can also set a reference to the at-risk Excel object library if you plan to reference any of the other at-risk objects. The role of the RiskXLA reference is the same as for at-risk. It provides a function, RiskOptimizer, that returns the root object, now called RiskOptimizer root. Here's RiskOptimizer root, and here's the function RiskOptimizer from the RiskXLA. Actually, you never have to spell out RiskOptimizer root in your programs. You can simply write RiskOptimizer, and the root object is accessed implicitly. The optimization settings sheet shows how you can change various settings for RiskOptimizer, categorized as engine settings, macro settings, and runtime settings. Note the hierarchy of objects. You start with the root object. You use its model workbook method to return an opt model workbook object. You use its optimization settings property to return an opt optimization settings object. You use any of its three properties to return a settings object of the type you want, and you finally change the appropriate settings. The sample code illustrates how this hierarchy works. It's much easier than it sounds. The optimization model sheet illustrates the most important parts of the RiskOptimizer XDK. You again start by referencing the model workbook object. Then you set up the model through the adjustable cell groups, constraints, and goal properties. And finally, you obtain results through the optimization results property. The goal is easy to specify. You indicate the cell to optimize, the goal type, usually minimize or maximize, the statistic to optimize, and if you are optimizing a percentile, the statistic parameter, that is, the percentage, such as 0.05. The sample code shows one possibility, where the 10th percentile of profit is maximized. Adjustable cells require more work in defining. In RiskOptimizer, adjustable cells come in groups, where each group uses a particular solving method, recipe, order, and a few others. You first add a group of a given type, and then for this group you add a collection of adjustable cell ranges, each with a specific solving method. The sample code adds two adjustable cell groups. In the first group, the recipe solving method is used, and two ranges are added. The first range must have values from 1 to 10, and the last argument, true, indicates that they must be integers. The second range must have values from 50 to 100. The last argument indicates that the discrete option with a step size of 0.5 will be used for these adjustable cells. In the second group, the order solving method is used. No arguments besides the cell range are required because this solving method simply finds the best permutation of the values in the adjustable cell range. For constraints, you use one of the 4 add methods, typically add hard in simple mode. Its arguments then define the constraint. In the sample code, one constraint is added. The arguments indicate that the 90th percentile of cost must be between 0 and 600. The first argument, opt evaluation automatic, is the best choice. It lets RiskOptimizer, not you, choose how and when the constraint will be enforced. Once the optimization model has been defined and optimization settings have been specified, you can use the optimize method of the root object to perform the optimization. Then you can use the optimize results property of the model workbook to access information about the best solution. The sample code shows some of the possibilities. The finish time minus the starting time, converted to seconds, and the best value of the goal. Once you understand the objects on this sheet, you should find it fairly easy to automate most RiskOptimizer tasks. However, there are occasionally times where you want to run another macro before, during, or after the optimization process. The Optimization Manager sheet illustrates how this can be done with the Opt Manager object. The sample code is a macro that would be run after each trial of the optimization. Here is how you would specify it. This macro checks after 100 trials whether the best value so far is the same as the value from the original solution. If it is, the Optimization Manager stops the optimization, reasoning that the process isn't getting anywhere. You probably won't use this type of code very often, but it is available. Now that you have seen the basic features of RiskOptimizer programming, take a look at the code in the RiskOptimizer XDK example files. You will see that virtually the same blocks of code are used throughout the examples, the main difference being the way the adjustable cells are specified for the various solving methods. Then you should be able to copy and modify much of this code for your own purposes.